Hello, my name is Joe, and today I'm going to be presenting a project titled Optimizing Steel Fabrication Process Using Machine Learning. In this project, we'll aim to address inefficiencies and waste in the steel fabrication industry, specifically those caused by suboptimal processes parameters. We propose using machine learning to predict these parameters, improving both efficiency and waste management. The problem we're tackling is the suboptimal process parameters that lead to inefficiencies and waste in steel fabrication. The key task here is predicting the optimal parameters for different processes in steel fabrication. For example, a user may input data such as the type of steel being used, which could be carbon steel, stainless steel. There may also be input field processes being performed, such as welding or cutting. Additional parameters could include the machine being used in its current settings, like type A cutter set to a speed of 5 milliseconds and a pressure of 3 MPa. Our system would take these inputs and provide predictions for optimal parameters. By using machine learning, um, we'll provide these predictions based on historical data, and we believe we can increase efficiency and reduce waste. Next, let's talk about the user design. Users or operators will interact with our system through a user-friendly interface with the following considerations. The interface will feature clearly marked fields for user to input current process parameters. For example, there might be a drop-down menus for selecting, um, you know, the type of steel and for the specific purpose, with additional input fields for the machine being used and its current settings. Then the data can be entered manually by the user or automatically imported from the machine if possible. We'll be transparent about this, explaining how we'll be using this information, and that there'll be a communication of uncertainty. User inputs are necessary for information, and click a predict button. Um, and then we will color code like a confidence bar. The goal of design is to make the system intuitive to use while also providing users with the insight how the system works and how certain it is of its predictions. In terms of privacy, our main concern is ensuring the secure storage and use of data about the machinery and its operations. We will comply with all applicable privacy laws, ensuring that our data is anonymized and cannot be used to identify specific individuals. One potential source of bias in our project could be if certain machines, processes, or operators are over or underrepresented in the historical data. To meet the goals of ethical AI, we aim to ensure fairness by considering all data equally, accountability by continuously monitoring and adjusting the model, and transparency by communicating how predictions are made and the level of uncertainty. We will implement the project by collecting historical data, selecting a suitable machine learning model, and then training the model on the data and integrating the model with existing processes. Finally, I'll show you a demo of the output. Um, this is a hypothetical demonstration of the system in action. Here you can see how the system predicts optimal parameters represented by the peaks of the graph based on temperature and pressure. Obviously, in our live system, we'll have many other factors for this prediction. And in conclusion, we have designed a system that uses machine learning to predict optimal parameters for steel fabrication process. By doing so, we believe the system has the potential to significantly increase and reduce waste in steel fabrication, leading to both cost savings and environmental benefits. Thank you for your time.